everyone, and welcome. My name is Josiah from InnoVision Medical Technologies, and I'm going to demonstrate today how to set up interoperability for your medical device. There are many things to consider when developing code to help medical devices send data to hospital systems. Data has to be appropriately defined, mapped, coded in a language, sent with secure protocols, and understood by the data consumers. One of the ways to reduce the labor of developing a digital communication interface is to integrate an interoperability library with many of these features already built in. This begs the question, how hard is it to integrate an interoperability library? Today, I'm going to show you how easy this can be. I'm now going to transition to a simple C++ demo. So here in front of us, I have on screen a small demo program. This is our legal comment. And then here I just have some pre-included headers, so I don't have to include those during the demo. I have a global Boolean variable here, which will help me to halt the program from the command line. I have a signal handler defined, which allows me to halt the program from the console, as I said before. I have the signal defined right here. I'm going to use Control-C. And then I have two constant variables defined here, a host and a port. We're going to be connecting to a small program I have on my local host using port 2575. And I'm doing this just for the sake of the demo, so I don't have to deal with user input. Okay, so let's set up our scenario. So today, we are going to be sending data from the Acme pulse ox, and we're going to send oxygen saturation and pulse rate to the super EMR. So all the data will be sent using HL7, just for this example. And to get started, I'm going to define that data. So I'm just going to create, at my global scope, a data setter function called setData. And we're going to use the InnoVision data cache. The InnoVision data cache supports monitored values such as measurements, settings, and mode, as well as waveforms and alarms. I'm going to define the time. This is just going to tell the system when we received our data. It's just for the purpose of this example. Your medical device would likely provide this information already. So I'm now going to paste in here our two values. So here, the oxygen saturation, I've set it to 95. And we're just adding a value to the data cache, creating it a monitored value, like I said, measurement, setting, and mode. And then here is the pulse rate, which I've set to be 67. These are static for the purpose of this demo, but this just represents the data coming from your medical device. So our library supports IHE PCD harmonized Rosetta and also allows for private terms mapping as well if that's needed. So the next step is to define some information about your medical device. So we're going to do that using the device profile. And here's the data that we're defining. So like I said before, we are a pulse ox, and we're located here at the Acme HQ. So our sending application, pulse ox, that uniquely identifies our application from any other application that the super EMR might be receiving data from. Next, the sending facility. So that's the organization responsible for our application. So I'm just saying in this case, the Acme HQ, their headquarters, is responsible for our pulse ox device. Then we have the EUI64, that's our device ID. And then our model manufacturer, Acme, and our model, which I've just said is the Acme pulse ox. So the next thing that we need to do is to define how we're going to send data to the super EMR. So in order to do that, I'm going to use the Interoperability Library's Interop client. This class is useful because it simplifies managing all the details needed for your device to be considered interoperable. So I'm going to give it our device profile here. And it also takes an interop context. So I'll just create an empty one right here. The interop context is used for more advanced topics like customization or extensibility. So I'll just go over a few of the options that are available there, but we won't get into that in today's demo. So the default objects used by the interop client are all customizable. So one example of this would be our network socket factories. So you could decide which type of socket factory you would like to use. And all of those components, so those objects set on the context or the client, those are all extensible. So you could create your own and define your own way to create network sockets. So this principle is applicable to all of our components and all of the objects that you can set on this context and this client. So from things like I said, the networking sockets, all the way to our messaging APIs, so how messages are created or parsed, and also including our data endpoints. So a data endpoint, as we will see now, is how you actually define who you're going to talk to. Let's do that. I want to talk to the super EMR. So I'm going to add a data endpoint. And I'm going to name this the default one because I know in this case I'm going to have no other data endpoints, but you could have more than one. I'm going to set my host and port. And then I'm going to set use TLS to false. Let me see if I can find, here's the right one. So here I've got my name, I've got the host and the port. Use TLS, I'm going to set to false. We're not going to use that for this demo. Not the right one, here we go. I also need a receiving app and a receiving facility because I'm going to be sending our data in HL7. So in this case, that's just going to be the super EMR for the sending, or the receiving application. I'm going to name the receiving facility to be the super EMR as well. Okay, so just to recap, we have created the data that we're going to send to the super EMR from our Acme pulse ox. I've defined my device profile, so this is who I am. I created a client and added a data endpoint to it so that I can actually send the data. So the next thing to do is to just run the client. And because I'm running this demo in the console, I've got some code which is going to help me start and stop the demo. I'm just going to paste that in. That's not really what this is about. Okay, so I'll just go over what I've got here. Here I'm checking if the client is running, and then I'm going to be setting that flag up above to true to show that we are indeed running. And then while the client is running and we haven't received any input from the user to stop, I'm going to set the data and I'm going to send the data using our interoperability client. And I'm going to do that every 10 seconds until I'm told to stop. And at the very end, we'll call stop to clean up. So what this represents, essentially, is as we're saying as data becomes available to our Acme pulse ox, we're going to send that. So here I'm just saying it's becoming available every 10 seconds. So that's just for the purpose of this demo. Okay. So let's actually compile and then run this example. Okay, here I have my console window up. On the left-hand side, I'm going to run the demo. And on the right-hand side, I'm going to run our quote-unquote super EMR. So I'm going to do this using an HL7 receiver that I built. It's just going to echo our messages to the console. There it is. It's waiting for a connection. So now I'll run the demo. And if we just give it a moment, we are now receiving data in our super EMR. So let's go over that. I'm going to go up here so it doesn't move. So here is our message that we received in the super EMR. And as you can see, right here, we're receiving the application. So we are the pulse ox. That's what we set in our device profile. This right here is the encoded version of our EUI64. Here is our sending facility, the Acme HQ. Here is our receiving application and our receiving facility, which are both the super EMR. So let's now validate the data. So down here is the pulse rate. And you can see that is 67, like we set it in the example. And our oxygen saturation, which is 95, like we set it in the example. I'll just show that. So here you can see oxygen saturation 95 and pulse rate 67. Thank you for watching this demo. I hope you enjoyed it. Have a nice day.